Good morning. I'm Hal Barbour from CAST. I'm here at the IPSoC 2013 conference in Grenoble, France. And I'm here to give you a quick report on what I've seen so far here and how it has effects or has influenced us on the things we're doing at CAST. Clearly the buzzword and the attention here is largely centered around the future and the Internet of Things. Internet of Things is a term that's been around for quite some time, and it's expanding. It's got various definitions. Written initially, it really had to do with the monitoring and tracking of things. But it's grown. It's grown into ambient intelligent devices that more affect the human being and what happens to the human being through the automation in the cloud in the system. Autonomous control for things such as automatic driver systems. There's lots of progress that's being made in both autonomous control, ambient intelligent devices, and the Internet of Things. Interestingly, there was a report by Ganesh from Gartner Group yesterday that indicated that on the real leading edge technologies, the actual number of design starts is going to go down, whereas in the things feeding the Internet of Things, in most cases, they're smart sensors and microcontrollers and microprocessors that don't require the bleeding edge, but they really require 65 nanometer, and the prediction that he had was that it was going to grow in the 10 to 12% area for things he calls fixed functions and microprocessors and microcontrollers. That kind of resonates with our thinking as well. And I got thinking about it, and I said, gee, just a couple of weeks ago I was with one of our customers in the valley that's really doing things very similar to this. They're monitoring power on the grid and controlling throughout the world power systems to balance the load based on user demand in real time around the world. A key part of their technology is noise reduction, to be able to actually communicate on the power lines themselves. At CAST, we see that not only are microcontrollers and microprocessors needed, as we have 8-bit and 32-bit processors that are doing very, very well, but people have really bought into the paradigm of PDAs. And they like touch and feel and the paradigm of swiping, etc. They don't necessarily need a PDA to do many things, but they do need some graphics. We just recently introduced a GPU from our partner Think Silicon in Greece that's really starting to get traction now. That's an example of a new assemblage of tools. So we've got GPUs, we've got CPUs, and other components. We also have a very successful product area of both video and image compression. But rather than just providing video and image compression solution or cores, what we're now doing is realizing that these images that feed them come from a sensor or come from a stored device, have to be pre-processed, they then have to be compressed, they then have to be put out onto the internet or into Wi-Fi or a wireless LAN. And we're providing integrated solutions of a number of our IP blocks that we can supply to a fixed function such as that. So it sort of resonates with what we're doing at CAST. It all kind of comes together for us, and we're quite optimistic about the future. Certainly as a small company, we are a small company amongst giants, but it's always been the case, and now we've heard this question time and time again, will you be around? Well, we just had our 20th anniversary, so we've been doing IP for nearly 20 years now. And we believe that if you have innovative ideas, you recognize opportunities where customer needs are, you don't have to be a giant to solve them. And I guess this gives me more optimism than ever to see what the industry sages are saying versus what we're doing. So that's the message from here. Hope to talk to you soon. See you then. Bye-bye.